Hello everyone, in this video we are going to see about the linear data structure, stacks and the queues. In the last video we have seen about the arrays and the linked list. Now let us see first of all what is a stack. A stack is a linear data structure. In case of an array, random access is possible, that is, any element of an array can be accessed at any time. Whereas in a stack, the sequential access is only possible. Actually, what is sequential access is, suppose if you want to take the fifth element, we have to follow the fourth, third. Actually, if you have to follow in sequence the first, second, third, fourth, and then to access the fifth element, that is called as the sequential access. But in the case of an array, random access is possible. What is random access is, suppose if I want to take the 10th element, I can say A is equal to x of 10. So now the 10th element of the array x will be stored into the element A. So we can choose any element from any part of the array, that is called as a random access, but that is not possible in the case of in the linear structure, which is a stack. It follows the principle LIFO, that is last in first out. So whatever the data which is put last, that is only the data which can be taken first. That is the last in first out principle. You can see over the picture over here. Here we are able to push and you have to pop the values. What is pushing is, we are going to insert. Suppose if you want to add more data into the stack, that is done by the push operation. So element is pushed onto the stack, and if you want to take the element, that is called as pop, and this is possible only from the top element. So we can take only the top element, we can pop the element only from the top. Okay, so this is then one-way transaction. In stack, we can insert the elements of a similar type. As we did in the arrays, stack also can contain only similar data type. The two operations are performed in LIFO, stack or push and the pop operation. So you can see this is the example of a stack where there's a stack of dishes. So just imagine arranging the dishes into a stack. Then we can take only the top dish first, then the next, then the next, and the last, which is pushed in, can be taken first, and the which is pushed first one can only be taken in the last time. Okay, now again a simple common example of a stack of biscuits that put in the bottle. We can take only the biscuits from the top of the jar and not from the bottom. So once you take everything from the top only, we can go to the bottom of the bottle. So that is the operation called last in first out. There are a few more operations in stack. So here, how to do the push operation? The push of x, it is an operation in which the elements are inserted at the top of the stack. In the push function, we need to pass an element which we want to insert into the stack. So here, push of x, that means this x will be pushed into the stack. So this push function has one parameter called x. And next is the pop function. It is an operation in which the elements are deleted from the top of the stack, that is removed. If you want to remove the element which is only from the top of the stack, so the function name is pop, and this function has no parameters. That means since you are going to always the top element will be popped, so there is no need to mention a pop of something. So pop naturally removes only the top element from the stack. So there is no need for any argument which you want to take. No need to tell which element you want to take. Naturally the top element will be taken out. So we need not have to pass an argument. So that is the difference between the push function and the pop function. So push needs the argument to say x has to be pushed in. But in case of pop, we need not tell what has to be popped out. Naturally the top element will be popped out. There are few more operations in stack. Peak or top. This function returns the value of the topmost element available in the stack. Like pop, it returns the value of the topmost element but does not remove that element from the stack. So here when you say top, this function will return which is the top element. So the answer of this function will be the element which is in the top position. But the difference between the pop and this top is pop removes the element from the stack, but top just to say what is the element in the topmost position. Next one is empty. This is an Boolean function which returns the value true or false. If the stack is empty, then this function will return a true value, or else it returns a false value. So here where this function is used, suppose if we want to take some element in the stack, if the stack is empty, we are not able to remove any element from the stack. So we have to, before doing the pop operation or the removing operation, we have to always check whether the stack is empty or not. We cannot remove anything from the empty stack. So this is empty is the function which returns the status of the stack, saying that whether the stack is empty or full. Likewise, one more function is full. This is the opposite function of this empty function. Here, if the stack is full, then the function will return a true value, or else it will return the false value. So sometimes if you want to insert some element, we check whether the stack is full. Every stack has some capacity, some limitation. We cannot push more and more elements onto the stack. So if you want to push any element into the stack, we have to check earlier we have to check whether the stack is full or not. If the stack is full, we have to say we cannot add more element. So that is the situation where the is full function is useful. So now here, if it is full, it returns a true value, saying that yes, the stack is full, otherwise it will return the value as false. These are all the operations that can be performed in the stack. Now let us come to the queue. Q is an FIFO, which means first in, first out principle. Q is also a linear data structure. It is an ordered list that follows of the principle of FIFO. We all know about the queue in common scenario. We stand in a counter to buy the ticket. We stand in the mall to pay the bill. So these are all the situations where here we have the queues. The first person will be served first and the last person will be served last. That is the principle of queues. In the case of the queue, we have two operations, insertion and deletion. So always we can add element and also we can remove the element. So insertion here, it happens at one end, so that end is called as an rear end. So the insertion takes place in the rear end. And next is the deletion operation, which is the removing operation, which is done as the front end, which means here this is the front person, he will be served first in the queue and will be removed from the queue. So the deletion takes place in the front portion. Suppose if someone want to join the queue, they will join at the back, that is the rear end. So two operations, insertion and deletion. So now let us see the operations here. So the operations are called as NQ and DQ. So what is the NQ means? When you insert the element, we are adding into the queue. So that is the entering the values into the queue, that is called as an NQ. And when you are deleting the value from the queue is called as an DQ. So the operations are called as NQ operation and DQ operation. We can see the picture over here. So this is the NQing operation where we are adding the data element from the back, and this is the front location where the data element can be removed, which is called as a DQ operation, and this follows the first in first out. So here there will be so many data elements based upon the queue capacity. So front element will be removed, that is the front end helps to remove the element, which is called dequeuing operation, and the back end helps to insert the data or the element, which is called as an enqueuing operation, entering the data into the queue. Now let us see the difference between the stacks and the queues. As you have seen earlier in the previous slides, stack is based upon the last in first out principle, where the elements inserted at the last and that is the first element to be removed. Insertion and deletion in stacks takes place only from the one end, which is called as an top. So top is the only pointer in stack operations. Insert operation is called the push operation and deletion operation is called as a pop operation. And then here in stacks we maintain only one pointer, which is called as the top of the stack, which always point to the last element present in the list. And finally, stack is used in solving works in recursion. What is recursion is repeated task, where the task will call itself is called as a repeated task. So stacks are used in the case of the problems where we are using the recursion principle. We'll see in detail how this recursion principle is done using the stack as the data structure. Now, regarding the queues are based upon the FIFO principle, and the elements are inserted at the first, and the first element which is inserted will be the first element to come out. And then insertion and deletion takes place from the opposite ends of the list. Insertion takes as the rear of the list, and deletion takes from the front of the list. Insert operation is called NQ operation, and delete operation is called as an DQ operation. And here queues have 2 pointers. Stack has 1 pointer, queues have 2 pointers, front pointer as well as the rear pointer. And then queues are used in solving problems having the sequential processing. Like here we are seeing in the previous thing how the persons entries are processed in the bill counter, how the tokens are processed. They are all coming under the sequential processing nature. So these are all the differences between the stacks and the queues. Both are linear data structure, but they work in different principles. Hope it is easy to follow, and thanks for watching.